Okay folks, we're at, I think this is video 6 that we're recording, and we're going to start looking at the cosine curve. Now remember, our cosine curve, we need to know the points where the cosine curve have critical values. So if I draw the cosine graph, we saw it starts at 1, then it goes to 90, then it goes to minus 1 at 180, then it goes to 270, and then peaks again at 360. So if I draw the cosine curve in here, dotted lines, then you can see that this curve is going to come back to minus 90 here, to minus 1, to minus 270, and to 360. So your cosine curve, as we saw in grade 10, runs 90 degrees behind the sine curve. We say they're out of phase by 90 degrees. Okay, so this will be y equals the cos of theta, the mother curve. Now remember, what we also said is that these things are the same. They behave in the same way that the sine curve does. So I want you at this point to pause the video and see whether you can do the other two in the same way that you dealt with sine. Once you've done it, unpause and see if you're correct. Okay, let's have a look. Here's our mother curve. Let's deal with this graph in blue. This suggests, like it did for sine, that all the cosine y values are going to double up. So here the y value is 1, the x value is 0. The y value doubles up, so it will go to 2. The y value here is 0, and I think 0 times 2 is still 0. This is minus 1. If we double it up, it goes to minus 2. Here we are at 0 again, and that point goes to the 1 doubled up. Here it goes to 0. We can in fact say that at all the zeros it remains because we're multiplying. This point at minus 1 becomes minus 2, and the point at 360 goes to positive 2. Okay, so there goes y equals twice the cosine of theta. That one was quite easy to draw. Okay, we make sure that we continuously curve it until we reach the point where it leaves. Now remember to give this coordinate pair. It's 360 and 2, and here we have minus 360 and 2 as well. And then your turning points, I think, are quite clear here. So that takes care of the blue curve. No period change. There is an amplitude change though. Here the amplitude was 1. Now the amplitude here will be 2. Okay, so let's look at the green curve, the one at the end. Now remember what happened for sine. For sine, because it became minus sine, we're ignoring the 1 first, it means the mother curve for cosine, like for the sine graph, is reflected in the horizontal axis because the positive y's became minus y's. So first of all, that point would lie here. The x-intercepts would lie exactly where they are, but the point where the graph is negative will now bounce positive. The point where it was positive 1 will bounce back or reflect back to minus 1. Okay, and the same continues on this side. It stays where it is there. The mother curve jumps positive, goes through the 0, then that last critical point gets reflected in the x-axis. Okay, so far the curve lies down here. And what do I do now? I raise it by 1. So this minus 1, let's not draw this one in just for now, the green curve. This is the curve that deals with the reflection. Okay, and that reflection I'm going to indicate in green dotted lines. So this part only is in the green dotted line for now. Then what must I do? I must add 1. So this point here moves up there to the cross. This 0 moves to the cross. This moves up 1. This 0 moves up 1, and the point where it's 0 there, or minimized, moves to the x-axis. And it continues here. It moves up 1. This one moves up 1. This one will move up 1 and that will move up 1, and this here is the reason why we add 1 to the transformed curve. So now finally I can draw it in a solid form, because this is the transformed curve that represents 1 minus the cosine of theta. This one here was y is equal to minus cos theta, and this one here is y equals minus cos theta plus 1. So the cos theta graph moved up 1 unit. Now you can see the x-intercept. There are points where the curve touches the x-axis, so those are the roots. The maximum values for the green graph is now at minus 180 and 2 and 180 and 2 over there. The period of the curve is still 360, nothing changed horizontally. The amplitude of this curve, remember, it's line of rest. If you look at it as a wave, amplitude is a maximum distance away from the line of rest. So the amplitude for the green graph here, the amplitude is still 1. The period for all three of these graphs remain 360 for the middle one and for the mother curve. Okay folks, I hope you got that one right. We'll be looking at some more of these in the next video clip.